Let's talk about nuclear physics. So in this video, I'm going to talk about some properties of the nucleus and how to calculate the radius of the nuclei. So under nuclear physics, we are going to look at some properties of the nuclei and calculation of the size of the nuclei. Then from there, we are going to move on to binding energy, radioactivity, the decay process, natural radioactivity, and nuclear reactions will mark the last subtopic under nuclear physics. But in this video, I'm going to discuss about some properties of the nuclei. So some properties of the nuclei, and in the other proceeding video, I'm going to look at what has remained. So a nuclei is simply composed of two types of particles. All nuclei are composed of two types of particles, which are protons and neutrons, except in ordinary hydrogen nucleus, which is a single proton. So a hydrogen atom has an atomic mass of 1 and proton number of 1. It do not have a neutron. So except for an ordinary hydrogen, which has simply 1 proton in its nucleus, other atoms or other nuclei has protons and neutrons in the nucleus. So this term here is simply the plural form of the word nucleus. So it is nuclei. So a proton and neutron is composed in the nuclei of all atoms except in hydrogen atom, ordinary hydrogen atom, which is a single proton. So a proton is simply a positive charge. It carries a positive charge, which is denoted by E plus, and it is about 1.602 by 10 to the power negative 9 coulombs, and the mass of a proton is 1.6726 by 10 to the power negative 27 in kgs. Then from there, a neutron is simply neutral. It has no charge. It has no charge, but it has mass, the mass of 1.6750 by 10 to the power negative 7 in kgs. So this table here summarizes the masses of a proton, neutron, and an electron. So the mass of the proton, neutron, electron in various units. So in kgs, the mass of a proton is 1.6726 by 10 to the power negative 27, and a neutron is simply the same, has the same mass as the proton. And in atomic mass unit, which is also called unified mass unit, it is 1.007276, and a neutron is 1.008665. But in mega electron volt per speed squared, it is a proton is about 938.28, and a neutron is about 939.57. So those are the masses of a proton and a neutron in various units, in different units. So you can express it in kgs, in atomic mass unit, and in mega electron volt per speed of light squared. Then from there, we have what we call the number of protons in the nucleus. So the number of protons in the nucleus is simply called the atomic number. So whenever you see the word atomic number, it is referred to the number of protons in the nucleus, and it is denoted by capital letter Z. And then from there, we have the number of nucleons. The number of nucleons in the nucleus, denoted by letter A, is referred to as the mass number. So the number of nucleons, remember the nucleon is simply the two constituents of a nucleus, which is simply the neutrons and the protons. So in other words, we can say the number of neutrons and protons is called the mass number. The mass number. So it is denoted by letter A. So given the mass number, which is the number of neutrons and protons, and the proton number, we can find the nucleon number, or the number of neutrons in an atom, using this formula here. This formula says the number of neutrons is equals to the mass number minus the atomic number, which is the number of protons. So let's have an example. We see how we can calculate the number of neutrons given the mass number and the atomic number. Remember, this A, we said it is the number of neutrons and protons. All together it makes the atomic or the mass number. And Z is simply the number of protons. So if you subtract the number of protons from the number of neutrons and protons, then you are going to remain with the number of neutrons denoted by capital letter N. For example, they are saying, what is the neutron number of the atom aluminium? What is the neutron number of the atom aluminium, given that number 27 and 13 there? So what you should know is that for all element denoted by a chemical symbol X, the number on top there, which is AA, is simply the mass number. So by definition, we say the mass number is simply the number of neutrons and protons. And the number which is down here, the bottom left corner here, is simply the proton number, which is the atomic number, the number of protons in the nucleus of that atom. So this comprises of the proton and the neutrons, and the neutrons inside. But this Z here is simply the proton number. So if you subtract this proton number from this number there, what you are going to remain with is simply the neutron number. So we are going to use this formula here to find the number of neutrons in the atom, in the nucleus of aluminium. So to do that, we are going to subtract. So 27 is simply the number of neutrons and protons in that atom, but 13 is the number of protons. So our number of neutrons, the number of neutrons, is simply equals to the mass number subtract by the proton number denoted by letter Z. So our mass number is 27 minus 13. So the answer should be just 14. So in the atom of aluminium, there is 14 neutrons. So we also have what we call the isotopes. So isotopes are simply nuclei of atoms of a particular element containing the same number of protons but different number of neutrons. So these are nuclei of atoms of a particular element containing the same number of protons but different number of neutrons. What they're trying to say here is that we have the same element, atoms of the same element, which have the same number of protons but different number of neutrons. For example, we have carbon. In this case here, carbon has the same number of protons. The atomic number here is simply the same. But when it comes to the mass number, is different. We have 11 there, 12, 13, 14. So this means that these elements here are isotopes. They have the same number of protons but different number of neutrons. Remember, if you subtract these 6 from the mass number, like here, we are going to have a 5, which is the number of protons. Here we are going to have a 6, here 7, there 8. So here we have 5 neutrons, here 6 neutrons, here 7, there 8, meaning they have a different number of neutrons. Or we can just define it as the atoms of the same element having the same proton number but different mass numbers. So these have different mass numbers. So that is what we call an isotope. So thank you very much for watching this video. That was just an introduction to the nuclear physics, which we have looked at the properties of the nuclei. And then from there, in the next video, we're going to look at how we can calculate the radius of the nucleus. Remember, don't forget to like, subscribe, and leave out your comment in the comment section below.